Hello everyone, myself Dr. I. Baranlingesan, Assistant Professor 3, Department of EEE, KPR Institute of Engineering Technology. And the topic today is we are going to discuss about electric vehicle technology. Before we enter to the electric vehicle technology, previous video we have discussed about the basics of automotives. In this basic of automotive, we have seen that vehicle performance, vehicle power source characterization, transmission characteristics, and mathematical model of the internal combustion engine. In this unit, so purely we are going to discuss about the electric vehicle. How this electric vehicle going to vary from a internal combustion engine. So first one, EV concept, state of part and configurations, parameters and consideration of electric vehicle, electric propulsion system, engine control unit. So these are all the compressed form of our electric vehicle technology unit 2. EV concept. A electric vehicle is a vehicle that uses one or more electric motors for propulsion. It can be powered by a collector system with electricity from extra vehicular sources, or it can be powered autonomously by a battery. EV include but are not limited to road and rail vehicles, surface and underwater vessels, electric aircraft and electric spacecraft. For road vehicles, together with other emerging automotive technologies such as autonomous driving, connected vehicles, shared mobility. So EVs from future mobility vision called connected, autonomous, shared and electric. Simply we can say it as a case mobility. Architecture of electric vehicle. The electric vehicle powertrain mainly consists of an electric traction motor. It is associated with power electronic converters and energy storage system and the powertrain controller. In a EV, the power electronics converters are used. These power electronic converters classified into two categories. One is a DC to DC converter, another one is a DC to AC converter. We can say it as a DC to DC converter, DC chopper, DC to AC converter called as the inverter. The energy storage can be a one or combination of electrochemical battery, fuel cell and flywheel. The control system is an essential part of electric vehicle and controls the various energy resources at various driving conditions. The battery is usually charged from the utility grid using a battery charging unit that can be placed on board or at the charging station. The basic architecture of the diagram of electric vehicle is shown in the following figure. It consists of a charger, battery, power electronic converter, electric motor and the transmission. Electrifying transportation is one of the promising approaches to solve the health and environmental problem. Thus, electric vehicles have been viewed as a substitute for the internal combustion engine. We know that internal combustion engine causes a lot of problems. In order to prevent from the environmental problems, we can use this kind of electric vehicles. The EV offer the possibility of zero vehicle emission, lower lifetime cost, enhances safety and possible renewable energy. However, the present EV technology is associated with the problem of limited range, high initial cost and longer recharge time compared with the internal combustion engine vehicles. We have a lot of fuel station for the internal combustion engine, but we can, when considering the electric vehicle, we don't have a recharge stations are very less. The limited range of EV may not pose a problem in many metropolitan areas and developing countries. One alternative for overcoming these disadvantages of EVs is hybrid electric vehicle. The hybrid electric vehicle technology can be developed to overcome the aforementioned shortcoming of both internal combustion vehicles and electric vehicles. The hybrid electric vehicle combines the internal combustion engine with the battery power electric motor, combining the advantages of both transportation. This includes low emission, high reliability, high fuel efficiency and long range compared with the internal combustion engine or electric vehicles. How electric or hybrid electric car work? A hybrid electric vehicles are powered by a internal combustion engine and one or more electric motors which uses the energy stored in the batteries. A hybrid electric vehicle cannot be plugged into a charged battery. Instead, the battery is charged through the regenerative braking and by the internal combustion engine mechanism. The battery can also power the auxiliary loads and reduce the engine idling when stopped. Together, these features result in better fuel economy with sacrificing performance. So this is a hybrid electric vehicle car. It consists of thermal cooling system and DC to DC converter, power electronic converter, and here we have an internal combustion engine for the spark ignition purpose. Next we have an exhaust system, and here we have a fuel filler for the internal combustion engine, and here we have a fuel tank for gasoline based power. Similarly, here we have a traction battery pack, and here we have the electric traction motor, here we have electric generator and transmission battery. So these are all the basic blocks and basic components of the hybrid electric vehicle. Key components of a hybrid electric car. So first one, battery. In an electric vehicle, the low voltage auxiliary battery provides the electricity to start the car for the traction batteries engaged. It also powers the vehicle accessories. Next we have a DC to DC converter. This device converts the higher voltage of DC power from the traction battery pack to the lower voltage DC power needed to run the vehicle accessories and recharge the auxiliary battery. Next we have an electric generator. It generates the electricity from the rotating wheels while braking, transferring the energy back to the traction battery pack. Some vehicle uses motor generators that perform both drive and regenerative function. Next we have an electric traction motor. Using power from the traction battery pack, this motor drives the vehicle wheels. Some vehicles use motors and that perform both drive and the regeneration function. Next we have an exhaust system. This exhaust system channels that exhaust the gas from the engine out through the tailpipe. Three-way catalyst is designed to reduce the engine out emission within the exhaust system. Transmission. The transmission transfers the mechanical power from the engine and electric traction motor to drive the wheels. So this is the architecture of the diagram. Here we have a level selection. First one, level 1, selection of the architecture, selection of powertrain, selection of components. Level 2, optimal size selection based on the constraints and objectives. Next here we have a level 3. This is selection of energy management strategy, classified into two categories. One is fuel consumption minimization, another one is the optical power sharing, and followed by we have a state of charge, preserving a cost and fuel economy. The diagram shows the high efficiency of the hybrid electric vehicle powertrain. The first level is the selection 1. First level is the selection 1. The selection of the architecture. There are 4 major types of powertrain topologies are there. One is the series, parallel, and complex. This selection plays a pivotal role in designing an efficient powertrain. The second level determines the required advanced technology components and their ratings to be integrated into a powertrain. These levels includes the choice of the energy storage system, electric motor, DC to DC converter, DC to AC converter. That stage 3 is the selection of energy management strategy. This is very crucial aspect that is responsible for maintaining the operation of each component and the overall system in the most energy efficient region. For example, energy management system is responsible for splitting the power demand between the electrical and mechanical power plant with the consideration of their efficient operating regions and their various constraints. Next we have types of electric vehicle. There are 4 types of electric vehicles available. One is that battery electric vehicle, fully powered by electricity. These are more efficient compared to the hybrid and plug-in hybrids. Next we have hybrid electric vehicles. From the name itself we can understand hybrid electric vehicle uses both internal combustion engine and the battery powered motor powertrain. The petrol engine is used for both to drive the charge when the battery is empty. These vehicles are not efficient as fully electric or plug-in hybrid electric vehicles. Next we have a plug-in hybrid electric vehicle. It uses both the internal combustion engine and a battery charged from an external socket. This means that vehicle battery can be charged with the electricity rather than the engine. Next we have a fuel cell electric vehicle. Fuel cell electric vehicle is the newest concept for this kind of electric vehicle technology. Electric energy is produced in the form of chemical energy, for example hydrogen. Next we have a configuration of the electric vehicle. The internal combustion engine replaced by internal combustion engine and fuel tank with electric motor, drive and battery pack, while remaining all the other components shown in the previous slide remain same. Drawback as it is heavy weight, lower flexibility, performance degradation have caused use